Hi, so in this video we're going to be looking to see whether two lines intersect and then finding the point of intersection. Okay, so if two lines intersect, there must exist values for lambda 1 and lambda 2, the lambdas for each line, which allow for the components of I, j and k to be equated. Okay, so what does that mean? If I have these two lines here, R1 and R2, and they'll have their own lambda 1 and lambda 2, and if they cross, there must be a value for each I, j and k components, which is the same in both lines, because if they weren't the same they wouldn't cross. Okay, so let's have a look. So looking first at I, we're going to equate the I values for R1 and R2. So I is 1 here minus lambda 1, and then for R2 it's 2 plus 3 lambda 2. So that's where the first one comes from. And then looking at the j components, there's no j there, but there's 2 lambda 1 j's, so 2 lambda 1. And R2 we've got minus 1 and minus 5 lambda 2s. That's where that comes from. And then the k, we got 2 minus lambda 1 for R1, and then for the k we got minus 1 and minus lambda 2. So now what we're going to do is solve these simultaneously. So just looking, I can see with 1 and 3, if I take 1 take away 3, that cancels out the lambda 1. So 1 take away 3. So 1 take away 2 gives me minus 1, minus lambda 1, minus lambda 1. Lambda 1's disappeared. 2 minus 1 gives me 3, and 3 lambda 2 minus lambda 2 gives me 4 lambda 2. So sort that out, and I get lambda 2 equals minus 1. Now I'm going to substitute this into, actually that should be substitute, yes, into 3. I could have substituted into 1, it doesn't matter, to get out my lambda 1. So I've got 2 minus lambda 1 equals minus 1 minus 1, and out of that I get lambda 1 equals 2. So I've got my values for lambda 1 and lambda 2, and I need to check that this works for equation number 2, because I haven't used equation number 2 yet. If it doesn't work for equation number 2, then I don't have a point of intersection. So let's put in for the left hand side, I've got 2 times lambda 1, 2 times 2 is 4, and on the right hand side I've got minus 1 minus 5 times minus 1. So minus 1 minus 5 times minus 1 gives me 4, and so the lines intersect. So if you're asked to show that two lines intersect, that's what you have to do. In the end, work out that the left hand side and the right hand side of the equation that you haven't used to solve simultaneously works. Okay, then if I want to find the point of intersection, that's quite straightforward now. I know a value for lambda 1 or lambda 2. I can work this out from either of the equations. I should get the same answer for both, but I'm going to do it with R1. So I'm going to substitute lambda 1 equals 2 into R1. So I'm going to get, putting it in column vector form. So this is I, j, k. So I've got 1, no j's, 2, 1, 0, 2, plus 2 lots of minus 1, 2, minus 1 here. And then working this out, I got 1 plus 2 times minus 1 gives me minus 1, nothing, plus 2 times 2 is 4, 2 plus 2 times minus 2 gives me nothing. So then from that I can say that the point of intersection is therefore at the point minus 1, 4, 0. So in this video we've managed to find or confirm that two lines intersect and actually find the point of intersection. Okay, I hope that's helpful.